flap. Alright everybody, welcome back to DCU Solutions. Today we're going to be covering question 11 of week 9 of the physics. Question 11, the general idea here is to think of volumes being conserved. Because in this question there's a large amount of water being squeezed through a pipe. And there's narrowing, and the pipe is obviously smaller here, with a radius of 0.2 centimeters for me. But the volume of water traveling through the nozzle is the exact same. The same amount of water is flowing through a tighter nozzle, therefore it's flowing faster, and it's asking us to find how fast it's flowing. Given water is incompressible, we don't have to do any complicated Young's modulus or any sort of strain compression or any sort of that, so we can just simply approach the question by considering volumes and lengths. So we can think of the water traveling through each section of the tube here, and in this large section as well, as just being cylinders. We can then just find the volume of the cylinders, and we can equal them to each other. Obviously, if the cylinders have the same volume but way different radiuses, like here, then that means that this shorter cylinder will obviously be much longer than the fat one, because they have the same volume. And the formula for a cylinder is the same in each case. So our formula for the cylinder is actually just pi or squared h. That's just the area of the circle. So that's that, and then the height. And we can just put two of these equations equal to each other, and that will help us solve this question. 1 squared 2.2 equals pi 0.2 squared h. Right, we've got our pi 1 squared 2.2 meters per second equals pi 0.2 squared h. And now it's just a simple case of working this out algebraically, and we can just use the calculator for that, and that's pretty much it. So pi by 1, and we can find that it's 55. The h is 55, so we can just write that down, which is the answer, because I've already done this question earlier. Generally, questions are made such that they're generally accurate to reality. So if you understand what numbers mean, and you can get a grasp of you can sort of imagine what's happening, you can obviously get an idea of if your number is way off or whatever. But 55 seems fairly reasonable. That's it. However, we can actually